Hello, children. It's your old pal, Mr. E, back for more parallel lines review. Here is the fourth one. A couple of proofs. Let's get right to them. Proofs. Given RS bisects angle KRT. I'll write that like that just for now. What? Okay. RS, that's this line here, that segment, bisects angle KRT, that angle there. So let's mark these as congruent because that's what an angle bisector does. The second given is this right here. Angle 1 congruent to angle 3, so let's mark that congruent as well. Here's 1, 3 are congruent, so all three of those are congruent. Looks like. Well, let's see. What's a key word here? Bisector, an angle bisector. That implies two congruent adjacent angles. That's what angles 1 and 2 are. So an angle bisector implies two congruent adjacent angles. There's a step that comes from here. Let's go this way. There's 1. Well, now we have 1 and 2 are congruent and 1 and 3 are congruent. So by transitive property, we could say that 2 and 3 are congruent. What does that help us with? If 2 and 3 are congruent, which they are by transitive property, well, then that would mean that this and this, those would be alternate interior angles, wouldn't they? To RK and TS. So let's go ahead and do that. Angle 2 congruent to angle 3. And that's all we need, really. Let's see, we use the transitive property. Congruency. That came from that box. That's where angle 2 was. Angle 1 was right there. So now that 2 and 3 are congruent, we can say that RK, ray RK, is parallel to ray TS because congruent alternate interior angles imply parallel lines. There we go. That wasn't too bad. That's from there. And we're done with that one. Let's go to the next one. Here's some lines. Let's see. Given G parallel to H, let's mark that. G and H, these are the horizontal ones. So these two are parallel. And then 6 is supplementary to 3. It's also given. I'm just going to circle these. 6 and 3 are supplementary. We want to prove that the two vertical lines here and here, we want to prove that those two are congruent. So let's see, what can help us link up 6 to 3 to prove that N and M are parallel? Well, 6 and 3 supplementary. What's supplementary right now between these two lines? What else is supplementary to 6? Or actually, let's go the other way. How about 3? What's supplementary to 3? Because these two lines are parallel, then angle 2 is supplementary to 3. Those are same side interior, so those would be supplementary. Whoa. Excuse me. Ah! Okay. I'm not sorry you had to hear that. So if 2 and 3 are supplementary, then, looky here, what are 6 and 2? Those would also be supplementary. Well, actually, no, they wouldn't be supplementary because, well, here, just look and see what we're doing. Okay, so because those lines are parallel, then 2 and 3, angle 2, that's an S, Mr. E. All right, angle 2, supplementary to angle 3, because parallel lines imply supplementary same side interior angles. All right, there's that. Now see what we have here. 6 is supplementary to 3, and 2 is supplementary to 3. So what do we do with those? Well, here's what we'll do. What do supplementary angles imply? Supplementary angles imply that the measure of 2 plus the measure of angle 3 equals 180 degrees. Supplementary angles imply two angles with the sum of 180 degrees. That's what they imply. Same thing here, and I'm going to write it up here. The measure of angle 6 plus the measure of angle 3 equals 180 degrees. Because supplementary angles imply two angles with the sum of 180 degrees. That goes there. Now looky what we have here. 6 plus 3 is 180. Let me highlight that for you. 6 plus 3 equals 180. Equals 180. And 2 plus 3 equals 180. So since they both equal 180, let's set them equal to each other, shall we? The measure, I'm going to rewrite this so it's in numerical order. So the measure of angle 3 plus the measure of angle 6 equals measure of angle 2 plus the measure of angle 3. It's a long one, but I think you can see what we've done here. This is, we use the transitive property of equality to make a brand new equation, and look what we can do with it. We have this angle and this angle in common on both sides. If we subtract that, what are we left with? We have the measure of angle 6 equals the measure of angle 2. That's subtraction. POE, and look why we did that. 6 and 2, if those two are equal, then those are alternate exterior angles between lines M and line N there, meaning that those would be parallel. So we need one more step. We're going to convert from measures into angles. So the angle 6 is congruent to angle 2 because equal, that's a Z, equal measures imply congruent angles. And our last step is that M, let's make it cursive, an ancient tongue cursive, well, not a tongue, but no need to write cursive these days, because let's see, what was that? Oh yes, these are congruent alternate exterior angles imply parallel lines. And there we have it. There's another proof done. So I will see you on the next video.